Hello everyone, and today I want to talk about metrics because this is a concept that we need if you want to go from beginner to intermediate, and this is the perfect time to start and learn about metrics. Because when I was doing some rotation and I couldn't understand how the rotation work in different by different types, like how we can rotate objects or how we can store that rotation attribute onto these points. So we need metrics to understand this first, and I will talk about how it works, what is it, and it took me a lot of time to understand this, a lot of mental cognitive energy. So I will just explain it to you, and this is like the really like precious for our skills if we want to go to the another level. So everything about metrics I will be demystifying today, and I will consolidating it for myself also. So really important thing first, I will you know I will go like from the very simple thing, and I will try to like explain it like step by step. We won't jump ahead and we won't be taking things everything at once. So we will go one step at a time, simple step at a time. I have this PDF, and this helps a lot. I created this, and just try to understand what I say because this will be huge. Okay, I have this object at the very center of this grid. First, I will talk about the world matrix. I will open PureRef and I will go in this video, and if I forget something or if I miss something, I will just go back to the PDF and we will look each step. I will explain it by myself, and then we will look into the PDF, and then we will understand it together. Okay, so we have simple nothing here. Let's draw something, right? I have this line, right? I have this, and we know that the world space has X, Y, and Z. But when these 3D softwares were created, we needed to have a base, right? A base for everything, and everything that we do in these softwares is relative to this world space. And what happened is that we dropped a single point in this world, right? We call this a single point, and we said that there is this arrow that is going up, we call it Y. There is this arrow that is going in this direction, left to right, we call this X. And there is depth, because first I will talk about 3D matrix. We have 3 rows and 3 columns, so it will be about 3 by 3 matrix. But the world matrix is 4 by 4 matrix, but it is a bit more complicated to understand it first. So we will talk about the 3 by 3 matrix first. So we have this, right? And we need to have depth in this 3D world. We just don't have like two components here. We have what's the word? We have this translation. Along we can go up, down, we call this Y. We can go left to right, we call this X. And we can go from in depth, we can go in depth, we call it Z. So we just put a point, and we have 3 arrows here. And how you represent those 3 arrows? We represent them by a vector. And you cannot just say I have this arrow and it is pointing in this direction, or I have an arrow which is pointing in this direction. No, it will be much more complicated, and we have 3 dimensions here. If we had 2 dimensions, we can easily say that it is in this axis, it is at this point, and it is in this axis, it has in this point. You cannot just say that there is this arrow which is going in the up direction. And why we use three components here? Because if you think about it yourself, if you have only one component, let's say I want an arrow which is going in the up direction, but there will be some questions that will rise, will rise. And the first question is from where? From where this arrow is pointing in the up direction. So we need its like its location also. So you cannot just say there is an arrow which is going in the x direction, right? And it is not comparing anything. We are not comparing this thing to anything. We are not comparing these components to anything. They are the base of everything, right? This is from everything. This is from where everything evolved. So we have this thing, and this stands alone, right? We are not saying that this arrow is going in this, because we are now first creating those axes in the 3D software. Remember this. So we'll say this y arrow is going in the up direction, but from where? So we have decided we need that point. When I talked about this point, so we have this point. So this arrow is going in the up direction, but from where? From this 0 point, right? From this 0 point. And this axis is going in the left to right direction. From which point? This 0 point. So it has this point which says 0 0 0. It is just a single point, and we then gave its direction also. Okay, now we understand something here, and this is where the cool things come, right? So we have three components, three arrows. And if you say, what is the method to store this data, this spatial data? And we call this, no, it's not special, it's special. Special here means space. We have this data of space. So we cannot just say that we have one arrow in this direction and it's let's say its value is 0, 1 and 0, because it is going in the y direction. So we have the single data, we have single data of this, and we have single data of this. Now mathematicians, I'm not a mathematician, and mathematicians created this type of data form. We call this matrix, and we call this matrix, sorry, I'm writing with my mouse, so it will be a bit it will look stupid. So okay, so we have this data type and we call this matrix. It is a container to store different spatial data into one, and it will make our work easier, because when Houdini needs to calculate different things, it can just calculate for this container itself. So we have this x data, spatial data, y and z spatial data. We have another component. No, we won't talk about it. I won't talk about it because it's complicated. It was complicated for me to understand all of this, but here I am talking about it to you now. So we have this x vector, which is this x arrow, which is going in this direction. So first we are creating the first base of everything, right? And everything we will do, we will just compare it with this data. So we have the x, and remember this is a 3 by 3 matrix I'm talking about first, and it is about direction. One more thing I will add, it is about direction. just ignore this, right? But you understand this is the direction. Okay, so we have x, right? And this is 3 by 3, but remember world space is a 4 by 4 matrix, but we are talking about 3 by 3 first. So we have x. Let's say, what is x? What we did with x? We said x is an arrow, imaginary arrow pointing in this direction. We call this x, and we call this direction 1. Its first component will be 1, other two components will be 0. So we have this direction now, right? It says, what about y? It says it starts from where x is 0, right? And it goes in the direction from x to upward direction, and we call it 1 in the middle component, and it will be our up direction. And we have similar, we have z, and it will be 1 in this direction, which will be our depth, and we call this, and from where x and y is 0. they are related to each other, but they are this first thing, it is independent. Now what we have this grid that we use in our softwares, in every 3D software. When we talk about 3D space, 3D spatial data, we talk about this because everything is related to this now. So we have this data type that we call matrix, and what it does, it stores different data types into one container, and we can do many things with it, right? Mathematicians create this, and I don't know more about this, but this is this is the very beginning of everything. So we have this data type now, and the recording is working, right? Yes. Okay, now what, we have this grid, right? One more thing I want to add, but first we will read this thing here, right? We will read this thing. So we need three components to describe this, because in this 3D space we have up and down, left to right, and we also move in depth, which is the z-axis we called it, right? Which we call it z-axis. We can just say that y is up and down. We also have to tell from where the y is up and down. So where the x is 0 and y is 0. Y, z and x are related to each other, but this whole grid thing, this whole axis components are independent. This everything, when we combine together, this x, y and z, this is independent, but this x, y and z is related to each other, because when you say y is going up, from where it is going up, where x is 0 and y, z is 0, right? Okay, okay, you understand this? I hope you does. We have the base now, but why use the metric? Matrix is just the data type. Here we are just pointing three arrows from a single point, which is the grid, and to represent the data, we are using the matrix. To represent that data, we are using the matrix, and it is a container to store those three different spatial datas, because we can put the data in one data like x1, y1, z1. Now we have a single data, but it says about a single point which is at the origin. It says about three arrows. Now this data type talks about three arrows which originates from this single point, and they are going in different directions. The arrow x is pointing in the imaginary direction we created as the base, y is pointing upward, and z is pointing in depth. This is what we understand about these world origin first. Now I will talk about this. What is the matrix? The core container. Matrix is not just an abstract mathematical grid filled with complex formulas. It is a computer graphic 3D graphic system like Houdini. It is highly specialized data type designed to handle multiple pieces of spatial information into a single container. Here spatial informations are these arrow vectors that we have here, and see, row 1 it x-axis, row 2 y, row 3 z, and the world matrix versus the object matrix. Now when we talk about, when I talk about, let's say when I talk about this box, you see, not box because box is similar in all directions. You see, we have this, it's translate, rotate and scale, which is at 0 0 0, rotate 0 0 0. Okay, now it's really important. This geometry is facing in this direction. Which direction? When we see this, when we say up, you see this, it is pointing in positive z direction, because it's front. We call it is front. So now we have this test geometry, and where is that notepad? Okay, we have this test geometry, we have its directions first, and I will call it, we have its matrix. I have this geometry matrix which can be, which represent its direction in 3D space. I'm talking about 3x3 matrix. I'm only talking about its direction right now. Its direction, not its location, because when we go to location, we need to focus on the 4x4 direction, 4x4 matrix. I'm only talking about its direction, right? Just remember this, because 4D matrix, 4x4 matrix is also stores its position and its rotation, but here I'm only talking about its direction for now, because that's what we need. okay, which represent its direction in 3D space. We have its matrix, and it's saying that its front is in the positive y direction, right? Its top is in positive, I'm sorry, its front is in positive z direction, and its top is facing positive y direction. So we have its front, which is facing positive z, and we have its top, which is facing positive y, positing positive y direction, right? And side is facing by, the side is like the side of the geometry is facing the x direction, positive x, or it is facing both, so we cannot say which side because it is similar. Okay, we have front, we have top, we have its matrix. when you when you create a geometry in this 3D space, its matrix is aligned with the matrix of this origin. So we will have the similar, the object matrix will be aligned with the origin matrix. That's the important thing here. And when we have this attribute warp, and when you go inside, you have this matrix transform node. We have this matrix transform node, and you look at this, we have its translate, rotate, scale, and pivot. And this translate, it's working in backend like as a matrix. Its data is going as a matrix. This data is going, we have these data, special data, right, which tells us translate, rotate, and scale, but this is one single data type behind the scenes, and it is like the matrix is now being compared, and the origin matrix is fixed. It is the base of everything. So now when we create a geometry, its matrix will align with this, and now we are seeing this, its front will be facing the positive z axis, right? This is how it works. So it is being compared, so the matrix are now aligned with each other. That's why when we create something, when we create pig head, it will face the same direction, because they already like put the matrix inside this and told this object that its face will face in the positive z direction. When I create a box has a matrix, of course. Why not? Because we have its direction. But you see what just happened. Wait, maybe I rotated this. Yeah, rotate. Okay, you see this box has similar sides, right? Right, we cannot say what's its front, what's its back, but you see this side is facing its, so that means its matrix, which is x, y, and z, its direction is aligning with that world matrix. So that means it's facing the world direction. So I will just open puref here, and I will just I can, yeah, okay, we have this, and let's create, okay, what I can do, I can just draw thing, right? Okay, we have this, and we have this, we have x, right, we have y, and we have z, we have x, v, and y, v, and z. This is local, that means it's the object matrix, and this is the world, which is the base matrix. So if the world says 1 1 1, everything is 0, right? And if the object x direction is, let's say in this direction, let's say its object is also 1 1 1, because it will align with it. So that means if they have said that it will face it said the positive z direction will be its face, it will align with this. So if you change these numbers, if you change these, let's say you want the x-axis to be this, let's say do I have a razor? Yeah, let's say you want the x-axis to be in the y direction. So what will happen, if the x-axis is the side of the geometry, it will face the z direction, and you will see that the geometry is now tilted or moved. It's like from its original location that we created. Okay, so now we understand that world is the base and object has its matrix, and we have their datas at the matrix form, in the matrix form. And now we will read this. The fundamental breakthrough is understanding how the master matrix is communicating with the world matrix. Does not point at a specific object, it presents the permanent absolute master root pointed ground truth coordinate. Where I wrote that? Yeah, here. You see this is the world matrix. When you generate a fresh piece of geometry inside Houdini, such as box, sphere, or pig head, its local orientation matrix is natively and completely aligned with the world matrix. It will align with the world matrix. If you say that its face will be in the positive z direction, then its face will align with the matrix, with the matrix that is facing in that direction that we created at first. So it will align in that direction if you stretch. Okay, now relative space and propositions. And the last thing that is really important here, I want to talk about, when we say I have this point, right? I have this point in this 3D space, and if I say a normal, now this point, compute normal, override normal. Wait, why I can see normal? Am I doing something wrong? Modify. Okay, what I will do, I will just attribute randomize, and it will create normal for us. Why I'm not seeing any normal? Yes, that's why. Okay, I was really close to that. Okay, now we have a normal, right? It is pointing in this direction. Normal is a direction with a magnitude 1, right? It doesn't have its magnitude. But if I copy 2 points, not curves, copy 2 points, and this is geometry to copy, and we have normal, you will see this. We have this. What if I increase its global scale, uniform dimension? Wait a second, am I increasing? Yes. Okay, here's the thing, it is not happening right now, but sometimes what happens that if you increase the magnitude of the normal and you copy some geometry onto it, the geometry scale, the geometry size can be affected by the normal scale, normal magnitude. That's why we say that to normalize our vectors if you want to copy or something, because that magnitude can interfere with the scale of your object. So what we'll do now, if this is not working, what I want to tell you here, that I want to talk about this matrix. This matrix is not just direction, it also has its scale properties, right? And to tell you about it here, what I will do, I will just move this here so we can have a much more bigger workspace. And how to draw. Okay, we have this matrix and we have this matrix. World axis has these units, right? Has these units because has its unit, and we call it 1 unit, and we can define this 1 unit by meter, centimeter, kilometer, right? But this unit is defined by this matrix, and how we have 1 1 1 as vectors, as those arrows. And when we said that these unit will be 1, this vector will be 1, we have a specific length which is 1. We have a specific length, right? And we created this by a random length, like every ruler is made from a random length. In the past, someone was with this stick and he called it 1 meter, and everything is related to that, or someone called it 1 centimeter. Oh, okay, I will call this space 1 centimeter. So it's like this. They created this and it called it 1 unit, 1 Houdini unit we call it, and it is based on this. The matrix, these arrows are of 1 unit. For example, these arrows are of 1 unit, and it also stores the scale of the object. If I say 2, 2, 2, that means we have now these arrows are twice, and this will affect our scale of this world. I hope you understand what I'm saying here, because this thing is crucial, right? It's important. So the world scale is at 1, but we can change the scale by changing this matrix value. And what happens when I create an object with 1, 1 and 1? We have value 1, 1, 1, 1, but if I want to change, when you change the scale of the object in the transform node, what is happening behind the scene? Its matrix values are changing. When you are saying I am stretching this object to 2, now you will see the object is stretched along the y-axis, but behind the scene its value is changing by your change, like by your number, and you said I want the scale to be 2. So what will happen? Its matrix value will be also changed, and you will get the same. Now when you put that object in this world matrix, and its matrix value, it got messy. So what I will do, I will just what this is what I will do. When you imported that object, when you created that object, and you put it in this world matrix, which is 1, 1 and 1. This is the world matrix, which is 1, 1 and 1, and you would when you put this 2, 2, 2 matrix object in this 1, 1 world, it will be twice bigger than this matrix, and we will see its scale as twice as big. For example, I will go in Houdini. When we have this test geometry, big head, right? You see it's aligned. It is of 1, 1, 1 unit. We cannot see it here because we are not changing, because the matrix is aligned with the world space. When I say I want to not uniform scale, I want to transform this. What is happening? I want to transform this in the y direction by 2. What happened? Its matrix, which was 1 when we imported this, now changed from 1 to 2, and now it is stretched, because in the world matrix it is not aligned with the world matrix. Now the world matrix says 1 unit, but this object has 2 units, so it will be of twice that length. So the object matrix and world matrix are now comparing. So we have that base. If I say the world matrix is 2, 2, 2, 2 in the y-axis, the y arrow magnitude is 2, then we will see this as the default scale of our object. I hope you understand what I said. And this topic, if you try to understand it by yourself, will what's the word? Will initiate a fire in your mind to just punch this monitor. But I tried to explain this. Just say this. Now everything is interrelated, like everything is related to each other, and we are comparing. We have this defined unit, and now everything is comparing with this. We are comparing everything with this defined unit. So I tried to explain metrics, and I won't leave because we have a PDF to cover. And if you stretch, if you just stretch an object to exactly twice as tall as its long vertical axis, the matrix transforms directly into the following state. You will see this is our scale. It also says direction, but it can also scale our object in the y. Its geometric length doubles. The rendering engine reads a specific line, changing in structure. Module 4, we have relative space and propositions. So if the world matrix is 2, if the world matrix says the unit is now 2, and when you put your object, it will be half the size of the world matrix, right? It will be half the size of the surrounding object world spacing. Matrix is a container holding 3 physical vectors. These are special data which we store into one container. We call it matrix, and it is of different types. We have the 3x3, 4x4, and I don't know what's the word for the matrix when it is aligned with it, when it is same as the world mate. I don't know what's the word, but if I recall it I will obviously say it in the next video. So scalar is not separate, it's entirely the magnitude length of those direction arrows, and all the special data is entirely relative to the parent of the world framework handling it. Okay, parent is the world that we created, or it is also when we parent objects with each other, so it is interrelated to each other. It's a bit on the advanced side. So when I create videos about when I go from intermediate to advanced, then we will talk about that also. So I hope you understand this thing, this matrix thing. And when nobody talks about this, and I hate that. When I was learning about attribute warp, this tutor, what he did, he put this X form node and he said, we are now translating this object by this form, and he didn't talk about how and why and how we are doing that everything, but I did. Okay, I have a lot to cover in this part, in this matrix part. First I will talk about matrix, then I will talk about rotation, because rotation itself is a very big topic, a very big concept to understand. So now I hope you understand matrix. Matrix are data together, everything, right? Okay, and this is it for this video. I hope you learned something. I hope you did, because I did. That's why I'm here telling you about this. Okay, I will see you in the next one. Until then, take care.